This is Sarah Hojati, Lab Section M04 with Lab 9, Physics of Extreme Sports with Ropes 2. The main objective of this lab was to examine the motion of a spring mass system in which the mass springs at an arc while oscillating. We can predict this motion by using the momentum principle and the energy principle. The result of this lab was that the period in the y direction was 1.61 seconds and the period for the x direction was 1.62 seconds. So here, we used a video that was given to us from WebAssign, and at the end point, we plotted the x and the y positions versus time to give us these two graphs, one showing the time versus the position in the x direction, and one showing the position versus the time in the y direction. I found the period in the x direction to be 1.62 by subtracting 3.14 minus 1.52, which is the beginning time of a period minus the end time of a period. I found the period for the y by subtracting 3.71 minus 2.10, which gave me 1.61 seconds. The initial conditions for this lab, which can be seen right here, are that the mass of the ball is equal to 0.402 kilograms, and that the initial position of the ball is at negative 0.109, negative 0.638, 0. The initial velocity of the mass is 0, 0, 0. We found the Ks to be 6.87 and the initial length of the spring to be 0.12723 meters. Once I run my code, as you can see right here, you can see that the blue ball, which represents the position of the mass from the video, and the orange ball, which represents the predicted position of the mass, are moving very close to each other, which means that the code is a good match to the data. The change in time was found by multiplying 10.5 times 20, because we did this 20 times. There are two forces acting on the mass, the force of gravity and the spring force. This force of gravity points in the negative y direction and is equal to the mass times the gravitational constant, and the other force acting on the mass, which is the spring force, is the spring constant K times the stretch S, which is also L minus L naught. The force is in the direction opposite to the stretch, which can be indicated by making S negative when you multiply the unit vector of the length. The net force is equal to the sum of the spring force and the force of gravity. The velocity update formula is found from the momentum principle, and it is the final velocity, and it is that the final velocity is equal to the initial velocity plus the net force divided by the mass of the ball times the change in time. The position update formula comes from the formula for the velocity, and it is that the final position is equal to the initial position plus the velocity of the ball times delta t. The energy principle states, or is also exhibited in this lab, and it tells us that the change in energy of the system is equal to the work done by the surroundings. Because our system is the ball, the spring, and gravity, and our surroundings is essentially nothing, we can say that the change in energy of the system is equal to 0. I found that the initial gravitational potential energy, I found it by multiplying the ball mass times the gravitational constant g times the ball position in the y direction. The initial kinetic energy was found by multiplying 1/2 times the mass of the ball times the magnitude of the velocity of the ball squared. I found the spring potential energy by multiplying 1/2 times k times the magnitude of s squared. The work done by the spring is calculated by finding the dot product of the spring force and the change in position, which is found by multiplying the velocity of the ball and by delta t. To find the change in spring potential energy, I subtracted the initial spring potential energy from the final spring potential energy. The change in energy is equal to the change in kinetic energy plus the change in gravitational potential energy plus the change in spring potential energy. Right here, we plotted the change in total energy and the change in spring potential energy right here. Excuse me, and the red line is the change in spring potential energy and the green line is the change in total energy, and this graph is correct because it shows that the change in energy is 0, which is the first law of thermodynamics. In this graph right here, we see the plot of the x position and the y position versus time for the predicted and actual simulations. The lines are very similar, which again shows that we essentially have an accurate depiction of our actual data. For the what does it mean question, the periods in the x and y direction were very similar, being 1.62 and 1.61, which can be explained because t is equal to 2 pi times the square root of m over the square root of k, which are both constants. The change in energy of the system is equal to the work done by the surroundings, which is 0 because our system consists of everything, the spring, the mass, and gravity. So the change in kinetic energy plus the change in gravitational potential energy plus the change in spring potential energy is 0. Finally, for the last part, we change the length or the initial starting position as it is shown here, as well as here. And so as you can see, the energies do not change.